Hello everyone, welcome back to my channel. Myself Arun Kaushish. In this video, we are going to discuss argument of complex numbers. First of all, we recall how to represent complex numbers on a plane. All the real numbers are represented on this real axis and imaginary numbers are represented on this imaginary axis, and this special plane is called complex plane or Argand plane. Now represent minus 3 plus 4 iota. Minus 3 plus 4 iota is represented at this point. On real axis it is minus 3 and on imaginary 4 iota. So minus 3 plus 4 iota is represented by this point, and a vector representing minus 3 plus 4 iota is this vector starting from origin to this point minus 3 plus 4 iota. So minus 3 plus 4 iota is represented in two ways. One, by this point minus 3 comma 4 in this plane, and secondly by this vector which starts from origin up to this point minus 3 comma 4, and length of this vector or this line segment is modulus of z, mod of minus 3 plus 4 iota. Now angle phi from positive real axis to the vector representing z, that is this angle phi, is called argument of z. And we can also measure in the clockwise sense like this. If we measure in the clockwise sense, then this clockwise sense measure is taken to be negative and the counterclockwise sense measure is taken to be positive. The measure of the clockwise direction is taken with negative sign. Minus 2 iota is represented by this point, and the vector representing minus 2 iota is this vector. Angle which this vector makes with the positive direction of x-axis is this angle 3 pi by 2. If we measure it from the clockwise sense, this measure is pi by 2, but it is in the clockwise sense, so we take negative sign. So argument of minus 2 iota is 3 pi by 2 as well as minus pi by 2. There, to be more specific, we define a unique value called the principal argument of z. It is that value of argument which lies in the interval minus pi to pi, which includes pi but excludes minus pi. So principal value of argument of minus 2 iota is minus pi by 2, as it lies in this interval but not 3 pi by 2. we denote principal value of argument z by capital letter A, argument z, by convention again. So principal argument z belongs to minus pi to pi, closed from pi, open from minus pi. Let us take one more example. Principal argument of minus 3. First of all, minus 3 is represented by this point, and the vector representing minus 3 is this vector. It makes an angle of pi with the positive real axis. That is this angle pi. And from the clockwise sense, it is making an angle of again pi, but with a negative sign. So the principal value of argument of minus 3 is pi, as it includes in this interval. Let us take some more examples. Z is equal to 3 is represented here. It makes angle of 0 with the positive real axis, so its principal argument is 0. 2 iota is here. It makes an angle of pi by 2 with the positive real axis, so its principal argument is pi by 2. Z is equal to minus 4 is making an angle of pi with the positive real axis, so its principal argument is pi. And minus 5 iota, its principal argument is minus pi by 2. Now see this. Next, if z lies in the first quadrant, then this angle theta is the principal value of argument z. Let us take example of 2 plus 2 iota. First of all, 2 plus 2 iota is represented by this point. Representing 2 plus 2 iota is this vector. Now to find the angle phi, first of all we find this angle, we drop perpendicular over there. This length is 2 units and this length is again, so 2 units, this length is 2 units, and modulus of this is square root of 2 square plus 2 square, that is 2 root 2. So to find this angle theta, we use T ratios. Tan theta is equal to 2 upon 2, which is 1. This implies theta is pi by 4, or our argument of this number phi is also pi by 4. Now if the complex number lies in the second quadrant, then our argument of z is this angle, and its value is between pi by 2 to pi. Let us take an example. Minus 3 plus iota root 3. The complex number minus 3 plus iota root 3 is somewhere at this point, and therefore vector representing this complex number is this vector. Now the angle which we want to find is this angle phi. For this, first of all, we drop a perpendicular from the point on the real axis. Now we find this angle. Let it be theta. This measurement is 3 units and this height is root 3 units. Root 3 units. Therefore, using t ratios, and what is this length? It is, by Pythagoras, it is square root of 3 plus 9, that is root 12 or 2 root 3. Now using t ratios, we have tan theta is equal to root 3 upon 3, that is 1 upon root 3. So this implies theta is equal to 1 upon root 3 is at 30 degrees or pi by 6. Therefore theta is pi by 6. And but what about phi? Phi will be pi minus theta, that is pi minus pi by 6, which is equal to 5 pi by 6. So phi is pi minus this angle theta, which is 5 pi by 6. Understand? So next is when the point Z lies in the third quadrant, the vector is this vector and the principal argument is measured in this way, because if we measure it from the counterclockwise sense, it will be more than pi. Therefore, we measure this angle and take negative sign with it. Let us take an example. Z is equal to minus 3 iota. The point minus 3 iota is at this point, and the vector representing minus 3 iota is this vector. Now principal argument of this complex number is this angle with a negative sign. Measure of this angle with negative sign. Now to measure this angle, first of all measure this angle, it will be theta. We drop perpendicular on the real axis and this measure is of 3 units and this measure is again of 3 units. This length is 3 units and this length is again 3 units. So what about this length? Modulus of the complex number, it is square root of 3 square plus 3 square, that is square root of 18, or 3 root 2. Now the angle theta is given by using T ratios. Tan theta is equal to 3 upon 3, 1. This implies theta is 45 degrees, which is pi by 4. Now what about this measure? It is negative of this measure, so this measure will be pi minus pi by 4. It is pi minus pi by 4, but we have taken the clockwise direction, so it is with a negative sign. So our principal value is equal to minus pi plus pi by 4, which is equal to minus 3 pi by 4. Okay. Now if the complex number is in the 4th quadrant, then the vector representing this complex number is this vector, and the principal value of argument z is negative of this measurement. Let us take an example. Z is equal to root 3 minus 3 iota. Root 3 minus 3 iota is represented by this point somewhere here, and the vector representing this complex number is this vector. Now to find this angle theta, we drop perpendicular from this complex number on the real axis. Now what about this measure and this measure? This measure is of root 3 and this measure is 3 units. This length is square root of 9 plus 3, 12, that is again it is coming out to be root 12, which is 2 root 3. So the angle theta is measured by using T ratios. Tan theta is equal to 3 upon root 3, root 3. This implies theta is equal to pi by 3. So our principal argument z, which is phi, is negative of pi by 3. So principal argument of this complex number is minus pi by 3. Hope that you understand all these cases and practice some more questions. So friends, the argument of z represented by arg of z is the angle phi from the positive real axis to the vector representing z. Its numeric value is given by the angle in radians and is positive if measured counterclockwise and negative if measured in clockwise sense. Also, argument z can have infinitely many possible values. This is because if theta is an argument of z, then 2n pi plus theta is also a valid argument. How? For example, if we measure argument of z by measuring this angle, then we can also have one more value of argument by measuring this angle, that is by completing one revolution of 2 pi and then again measuring this angle. So if phi is one argument, then phi plus 2 pi is another argument of the same complex number, and so we have many arguments for a given complex number. But to be more specific, we define a unique value called the principal argument of z. Principal argument of z is that value of argument which lies in the interval minus pi to pi, where pi is included but minus pi is not included. We denote this principal value by capital A R G of z. This principal value is unique for a given z. Let us take example of 2 plus 2 iota. Its principal value we have discussed is pi by 4. So one value of argument z is pi by 4, but there are many more values of argument z. One such value we can show is by measuring this angle 2 pi plus again pi by 4. Similarly, if we go on completing one more circle, then this argument will be pi by 4 plus 4 pi. And if we go in the clockwise sense, then this angle will be minus 2 pi plus pi by 4 and so on. So there are infinitely many values of argument z, pi by 4 plus minus 2 pi by 4 plus minus 4 pi, so on, but only one value of principal argument z, which is pi by 4. Similarly, we have discussed that principal argument of root 3 minus 3 iota is minus pi by 3, but its argument can be minus pi by 3, minus pi by 3 plus minus 2 pi, minus pi by 3 plus minus 4 pi, as we can measure this from the positive real axis in this direction also, and we get this angle is 2 pi minus pi by 3. Now there is a relationship between argument of z and argument of z conjugate. Argument of z conjugate is equal to negative of argument of z. Very important relationship. We can see, let z be this complex number and vector representing z is this one. Similarly, its z conjugate is below x-axis is this point, and its vector is this vector. Now this length is mod of z and this length is mod of z conjugate. Since mod of z conjugate is equal to mod of z, so these two lengths are equal. This is a common side between the two triangles, and the length of the perpendiculars dropped are also equal. So the angles, these two angles are also equal in measurement, these two angles, but this angle we have taken in the counterclockwise sense, so it is positive, and this angle we have taken in the clockwise sense, so it is negative. Therefore, argument of z conjugate is negative of argument of z. We can see with one more example. Argument of root minus 3 iota we have discussed in this video is minus pi by 3, and argument of its conjugate, that is root 3 plus 3 iota, is pi by 3. Therefore, argument of root 3 plus 3 iota is negative of argument of root 3 minus 3 iota. Hope you enjoyed the video, and please like, share and subscribe my channel. Thank you.